In a previous video we were looking at this problem right here, this program, where I talked about this 9 divided by 2 is an integer division giving you an integer result only, so you lose the decimal places. So in this video we're going to correct that problem and explain what casting is. Alright. In this situation, again, we have two integers having division. Immediately the decimal portion is lost. So when you subtract the 3, really all you're doing is subtracting the result of the division, the integer portion of it, and you're subtracting 3 from it, even though the variable you're assigning it to is a double. The way to keep it is what we would have to use casting, which means one of these two values, either the 9 or the 2, needs to be cast to a double. Alright. And what that basically does, it promotes a value, and we can also do it to variables, to the new data type. Right? And we do in C++, we have what's called the static cast, right, which looks like this. Static cast, and then inside these brackets you want to put in the type you want to convert it to. So in this case, it's going to convert the 9 temporarily to a double, and then give you the division based on the double, and then it's going to subtract the integer from that value. Alright, so let's run this program now. Right, before, remember that we would only get an integer value, and oops, sorry, I'm missing my parentheses around the 9. Here we go. Alright, and our results here, you now see it has a 1.5. It has a decimal. Without the static, it was only giving us the 1. Right, so that's what we call casting in C++. This is the C++ version using the static cast up front. I can cast this to anything else, doubles, to ints, to floats, to chars, and anything else that we want. Right, so to fix this problem though, we want to cast it to a double so we don't lose the decimal place. Or we can do a float, which also gives us the decimal place. Another solution or a way to get around it, right, and then we'll do it with some variables. So we'll add 2 more variables here. Alright, and we'll set denum1 equal to some value. Right, put 5.6 there. Alright. So if I was to do denum again here, right, without the casting, and I would use that denum1 now, divide it by the 2, and then subtract the 3. Alright, and we'll get rid of this statement since no need to do that calculation. Right, so we should see the denum output again be some kind of decimal value. Right, just put a random number in there, and our results comes back, in this case with a negative decimal value. Right, so the variable's already a double, so that we'll do double division here, floating point division here, and then subtract the 3. So you don't need to cast in that example. But if the value really is just going to be an integer value, like a 9, right, to assign it to a double, it's kind of silly just to get around this problem. Right? You should be using the cast, but it will work because the data type is a double, as you'll see here. Right, we're back to the 1.5, right, because this variable is a double, even though it's only assigned a 9. It's doing the 9 divided by 2 as a double division, floating point division. Alright, so that's a way to fix that. And all what casting is doing a promotes a lower class data type up to its upper class. Or you can go downward also, demoting. You can take a double value and cast it down to an integer, which means then it will lose all its decimal places and just keep the whole portion, the whole number of the value. Okay, so we can go up or down either way. So that's the uses of casting. And besides this division, there are other instances where you want to use it. But C++ does support 2 older C styles. So if you're looking at older programming, you might see something more of this nature. Some of the old code, or even the old time programmers, I find still do this form of casting, okay, where they'll take, right, that's going back to where we were, and now they will do, instead of putting all that static cast in there, just do the old-fashioned seek style, which will be that nature, and you'll get the same results. It'll do the division as a decimal, a floating point division, right, so you'll get the 1.5 value there again. Right, that is one way of doing it. Right, again, that's the old C style of doing it. The other way, it's basically the same thing really, but instead of putting the parentheses around the double, oops, they put the parentheses around the value that they want to cast into it. Alright, again, still giving you the same result of 1.5, but there's just two different ways of the old C style of casting. It will work even if you're writing a pure C++ program. You can use those castings, but the standard is to use the static cast, since it is a C++ standard and it's built for the C++. Right? C does not have that static cast.